Hi everyone, and welcome to this ASHRAE Ireland webinar on the topic of digitizing buildings with brick to enable portable analytics, modeling and controls. And we're delighted to welcome Carlos Duarte from the Centre for the Built Environment in UC Berkeley to join us this evening. So before I hand over to Carlos, I'm just going to cover some housekeeping in terms of how you can interact with today's webinar, and then there'll be today's presentation of around 40 minutes before we pause for some Q&A from the audience, and we'll finish off with a couple of closing announcements. Sorry, I've realized I've not adjusted the time. Normally we have these webinars at lunchtime, but appreciate it. We've got Carlos joining us from the west coast of the US today, so we've adjusted the time to suit. So just in terms of housekeeping, if you want to ask a question, you can do so at any time during the session. Just type it into the chat function. At the end as well, we'll also have a chance for people to ask questions directly if you want to unmute yourself. But I just ask that if you want to do that, just use the raise your hand function in Zoom, and we'll let you know when you can unmute yourself, just to avoid people talking over each other. Lastly, if you do have any difficulties with technical issues or sound or anything today, you can always email us during or after the seminar at the email address shown. Handouts, so presentation material, will be available in the chat in the next couple of minutes. I'll post it into the chat when I hand over to Carlos, and also we'll make it available on our website later on, probably tomorrow or early next week. So this is part of our 2021 technical events and webinars lineup. So we're coming towards the end of this year's lineup of virtual events. We've had a fairly packed schedule this year. We've been delighted to welcome not only local speakers from UK and Ireland, but also international speakers and distinguished lecturers from ASHRAE's DL programme. I'd just also like to highlight the availability of further education and training sessions through the ASHRAE Learning Institute, which you can access through the ashrae.org website on the professional development page. So I'm going to hand over now to Carlos Duarte. As I said, he's a postdoctoral researcher at the Centre for the Built Environment at UC Berkeley in the US. So Carlos received his PhD in architecture with an emphasis in building science, technology and sustainability from UC Berkeley. And currently he's working on this topic that he's going to talk about today in the area of portable analytics and control applications in order to handle the large quantities of data and controls for modern buildings. So I'll hand over to Carlos and stop sharing. Okay, over to you, Carlos. Thanks very much.
Thanks, Daniel. I'll just start sharing my screen here. Can you see I think you can see my screen.
Yes, yep, perfect.
Okay, thank you. Thank you for that kind of introduction, Daniel, and thank you for the invitation to this webinar series. So today I'm going to talk about digitizing buildings with brick to enable portable analytics and modeling and control. So this is a big project that has a big interdisciplinary team from UC Berkeley, from the Lawrence Berkeley Lab, the Pacific Northwest Laboratory, and the Colorado School of Mines. So let's get started here. So buildings with digital control systems produce a large amount of data. This includes a significant majority of commercial buildings which have some type of digital control for their HVAC or lighting systems. However, the data that these buildings are producing are only being used within the control system to just do basic building operation and then discarded. Building operators don't usually do historical trends unless a occupant complains. Then they might be able to start some of the trending to figure out what is the root cause of the problem, and only if they have time. But most of the time, it's just the data is just discarded. As a result, these digital controls have become an underutilized resource where only a few percentage of the buildings actually use digital controls to implement some kind of advanced functionality. This includes energy consumption and optimizations, predictive maintenance, fault detection, and diagnostic tools. All of these are missed opportunities to make buildings more energy efficient and increase occupant satisfaction. And the main reason for this is because control vendors have their own proprietary systems that make it hard for one system to talk to another. Control vendors also have their own conventions to implement the controls and identify and give meaning to the control points and the controlled equipment. And you can't forget that buildings in general are very different from one another. And along with their HVAC systems and lighting systems, most often they're unique implementations for each of the building and their occupants. So this makes it hard for me, for you, or for anybody else that wants to come into a building to collect the necessary information and give meaning to the data points so we can actually use the building data within our own building applications. And if you want to apply the same application into another building, then we might have to deal with a totally different system and repeat the whole process of trying to just understand the data streams and where they are coming from. So this is not a scalable solution or very cost effective. So today I'm going to talk about this new tool called Brick that breaks some of these barriers to implement applications that can easily scale to a large number of different buildings with little or no modification to the application itself. And we do this in 3 steps. We first describe the building using standard labels and relationships. And these standard labels and relationships are defined by Brick. And next, we retrieve the necessary information using those standard labels and relationships. And finally, the only thing we have to do is analyze the return data and information to provide knowledge that decision makers can act on. And this project is funded through the U.S. Department of Energy, CBE membership, and Johnson's Controls. So to put it more specifically, Brick is a formal representation for describing buildings, their systems, and the information they produce. The initial ideas of Brick started within this group of institutions that you see here about 5 years ago. They weren't the first one to attempt to standardize the description of buildings and their things inside the buildings, but they realized that existing solutions were not well equipped to capture the relationships and entities required by applications that analyze building data. So then Gabe Fierro, a recent UC Berkeley PhD graduate from the computer science, has led the development of Brick to what it is today. So one of his guiding principles of Gabe is, in leading this effort, is that we can develop self-adapting software that uses information about the building in order to discover the relevant data and execute the appropriate logic, regardless of the complexity and the uniqueness of the building and its systems. And one of the ways that CBE is helping with this effort is by developing applications that showcase the capabilities of Brick. And we're going to talk about 2 of them today. So Brick uses drawing. There's an industry consortium that oversees the development of Brick. Many companies are beginning to incorporate Brick into their products, and institutions and research centers like CBE are using it to facilitate research. It's open source and flexible, so anyone can use it free of charge and adapt it to their needs. In addition, Gabe is working closely with ASHRAE to develop a new standard to standardize the description of buildings for use in building applications. So Brick is going to be well integrated with this new standard. However, one of the things that self-adapting software is that they require rich, meaningful, and machine-readable descriptions of the built environment. However, when we download data from a building energy management system, we often get labels like this. This is a real label from a building here on campus. And there is a lot of encoded information within this label, but there's no easy way to extract it unless you have some insight on the naming convention used to create it. This label, for example, incorporates site name, the associated equipment, IDs, zone, room numbers, some random padding characters, and finally ended by the actual data stream information from this label. And sometimes there is even implied information. For example, the value of this air temperature set point might actually be determined by someone adjusting the thermostat. Or there's a middle equipment like a VAV box between the air handling unit and the zone there to distribute the air. So we might be able to decipher these labels, but it could be a real challenge for computers to infer the information available within this. There might be computers that can infer the information once you have the naming convention, but then you really don't get the full relationship. And to get this, we often need to go through thousands of pages of drawings or equipment schematics to really get this relationship within the building. And furthermore, these naming conventions are not consistent throughout the building industry. Each control vendor has their own naming conventions, and the conventions vary even with the own concerned vendor. It just depends on who is actually implementing the controls for that day. And they could be misspelled, they could be switched. Some of the naming conventions can be switched around within the label. So even if you develop a computer software system that infers much of these labels, it's not going to be always very precise or very scalable to other buildings, because as I show you here 3 examples, and all the 3 examples have just 3 different totally inconsistent labeling mechanisms. So this is where BRIC comes in to try to standardize this labeling conventions for describing buildings. And BRIC starts with 3 main concepts that serve as a root node for a class hierarchy. These concepts are equipment, point, and location. And as we drill down to the next level, we get more specific labels within each of these 3 concepts. For example, the equipment node, we now have HVAC, lighting, electrical, fire safety, video surveillance, etc. Equipment within the main equipment concept. Similarly, if we go another level down, we get more specific labels to describe our HVAC equipment, eventually reaching a point where the label can be specific enough to assign to an individual component in the built environment. Relationships are also an important component to BRIC. They dictate how entities correspond and relate to each other. For instance, the DOAS system here feeds into a VAB box, and that VAB box might be located within a private office. That private office can be part of a larger HVAC zone. And we can also attach sensor points, set points to the different equipment or the locations in the built environment. Here, I'm just showing a discharge error sensor point attached to the VAB box. So now let's see how BRIC is used in practice by applying it to a hot water plant shown in this schematic. And this is coming from a real example where I used this building and this building's hot water plant to implement a control strategy that I'm going to talk in more detail as I go on through the presentation. And so BRIC is designed for usability. We can essentially treat BRIC as a dictionary of labels that we can use to tag our building assets. So the first thing that we need to do is identify those equipment assets within this hot water plant. Again, we see labels that are inconsistent and loaded with information. And like I mentioned earlier, these names are fine for humans, but can be a challenge for computers to infer. So we need to use BRIC to give meaning to these components in a way that computers cannot understand it. Here, I'm just using brick equipment labels to tag each of the equipment assets shown on this schematic. And so we have valves, we have a heat pump, we have a boiler, and all of these specific labels have a specific definition within the brick ontology that makes it easy for the computer to understand what we are trying to describe and to infer connections later on. So let me rearrange the building assets and hide some of them for now. So we can proceed to assigning relationships between the components. Here, for example, the boiler on the bottom right feeds into a hot water loop. That hot water loop feeds into an air handling unit, a heat pump, and another water loop that eventually feeds into the radiant system of the building. We can also attach points to the equipment. So here, I'm just showing that we attach supply water temperature sensors and a set point, and along with a run temp sensor to the boiler here. And the neat thing about this graph is that we can start from the boiler, for example, and see which rooms use the hot water produced by the boiler. Or the only thing that we just need to follow those arrows from the boiler until we reach some room components in this graph. Or we can start from the rooms and follow the arrows in the backwards direction and see which equipment affects those specific rooms. In this case, it includes the boiler. So bringing it all together allows any application to discover and infer connection and information with this graph model to use within our own applications. And the neat thing about this is that this is all happening in the background within Brick. Brick has an inference system that makes a lot of these connections. So the only thing that we would have to do is retrieve that information from the graph model. And to do this, we use another tool called Sparkle. And this is just a query language for graph models like the one we just created. And we can use Sparkle to find answers to questions like, what are the hot water end users of the boiler? A successful query will not reference any labels specific to the building. We are just going to use the labels defined by Brick. And in doing so, we can apply the same query to another Brick building model and retrieve the same kind of information. And the answer to this particular query for the graph that you see here, the query is going to return the air handling unit, the heat pump, and the tabbed radiant panel. So a follow-up question could be, how many of these hot water end users are requesting hot water? The query might ask for the controlling valve status, the mode of the end user to figure out if it's in heating or cooling mode. And with these two pieces of information, we can infer a request for hotter water. And the only thing we have to do is count them up and send it over to an application so it can do further process this information. And this is exactly what we did. We created a portable controls application that is using the capabilities of Brick and related tools to implement a real control strategy in a building. And this control application that we created is a hot water supply temperature set point reset. And we applied it to a building here in downtown Berkeley. The goal of this hot water supply temperature reset is to modulate the hot water temperature up or down to match the building's heating load. And in matching the supply water temperature with the heating needs of the building, we can actually increase the overall efficiency of the hot water plant. So the first step was to create a Brick model for this building. And I already showed you how we did that. And this Brick model, we are also able to include backnet information so we can retrieve live data directly from the energy management and control system. So now that we have the Brick model, the next step is to question the model so we can identify all the hot water end users from the plant and figure out if they are requesting hotter water. And I also already showed you how we can develop queries to retrieve the information from the model. In addition to retrieving equipment and point metadata, we are also retrieving the necessary backnet information for this equipment so we can get live updates from them. So now that we calculated a number of hot water requests for our hot water plants, we can send it over to a controller so we can calculate a new hot water set point for the pointers. The interesting part here of this step, of the controller step, is that we're taking a controller from a previously built library of controllers. ASHRAE has developed Guideline 36 to standardize best-in-class HVAC control. So a group of experts already thought on how best to design these control sequences. So they have already been proven to have high performance. And the experts at LBNL took it a step further and programmed these sequences using a standard language, which is part of a larger effort to unify and streamline the whole process of control sequence testing, evaluation, and real-world implementation. So we don't have to reinvent the wheel here. We are not designing the control sequences. We are not programming them either. So we're reducing deployment costs along with errors that might be introduced in the programming. So the integration of bricks, backnet, and standardized sequences means that in theory, we can just replace the David Brower Center, the building that we use in Berkeley, with any other building with a hot water plant. And in theory, there's going to be no change in the workflow or in the programming logic, further reducing the deployment costs of designing control systems and buildings. So I just talked about portable controls that use as a use case for bricks. So now let's switch gears and talk about portable analytics. Like I mentioned earlier in this presentation, there's a lot of missed opportunities to increase energy efficiency and occupant satisfaction by just analyzing historical data that digital controls produce. One such application is the long-term evaluation of thermal comfort for the building. That is a building generally providing indoor temperatures that are comfortable for people. And for the rest of the presentation, I will focus on this use case of bricks and on how we use mortar to facilitate the development, testing, and the impact of specific thermal comfort evaluation applications. So let me first describe what mortar is. So mortar is a large, diverse, and consistently updated collection of buildings and building data. I believe you had Clayton Miller from the National University of Singapore give you a talk a couple months ago. And one of the things that Clayton often discusses is the lack of building data where we can test our building applications and prediction models. It is often that researchers develop these nice and fancy applications, but they only test them on one building. You can't really tell how good your application is or how impactful it might be because you're only testing it on one building. So this is where mortar comes in. Currently, it is a collection of over 100 buildings with more than 26,000 combined data streams. And each of these buildings has a brick model, so you can easily retrieve the required data from them. And since these are brick models, you only have to write one query to retrieve the same kind of information from all the buildings if the data stream is available. Some buildings may be very complete data sets where they have plant, distribution, and zone level data, while others can be pretty limited, only having zone air temperature data, for example. So we are always looking for more data to add to this open source database. So if you have any or know of a building owner that is willing to donate their building's data, please let us know and contact us through email. So we can evaluate long-term thermal comfort in various ways by only using a continuous stream of indoor air temperatures. Each metric will have different correlations with the subjective responses of the building occupant. So we develop a standard workflow to do this evaluation, where we first query the brick model to figure out if the available data if the available data for each building is available within the mortar test bed. Then we download the data from the mortar test bed if it has built zone temperature data. And finally, we just analyze the data to calculate the desired thermal comfort metric. The advantage of brick and mortar is that we can run this application on different levels of granularity. For example, we can start by quickly analyzing the portfolio of buildings to get a quick overview of how buildings are maintaining indoor thermal comfort. Then we can just start drilling down to more granular levels if we start seeing issues. In the same way, we can change out the thermal comfort metric to calculate without changing any other components of the application, since we receive the data in the standard form from each of the buildings. So in this presentation, I'm just going to use the range outlier method as an example metric to evaluate thermal comfort and show some results. So I can't stress it enough, but having a standardized way to describe building assets means that we only have to write one query to retrieve the same information across a variety of different buildings. In this example, we are using the mortar data set. In addition, we can query for the relationships between one equipment to another, as well as the relationships between the spaces of the built environment to that specific equipment. Having these relationships allows us to quickly determine where or what might be causing thermal discomfort. We can figure out if it is at the air handling unit, it's, for example, not performing as expected, or is it a problem at the VAV box, or it might be just a west-facing room that has a hard time maintaining comfortable indoor air temperatures. So now that we downloaded zone air temperature data, we can start analyzing it to evaluate occupant thermal comfort. So here I just showed two sets of box plots of zone air temperatures data that we retrieve for each of the for various zones of a single building. The top set of box plots shows air temperature distribution during the summer season, and the bottom set shows the air distribution during the winter season. And the horizontal dashed lines in each plot represents the calculated thermal comfort limits. One of the first things that you might notice in these air temperatures is that during the winter, the air temperatures are usually within the thermal comfort bounds. However, for the summer, the majority of the zones are being overcooled, and there is a possibility that the middle zone that you see there, the one that stands out, 1056, might be driving the overall cooling needs for this floor. So we need to take a more detailed look at the equipment supplying this zone to figure out if there's an issue, and we can use bricks to really quickly retrieve this kind of information. So now let's look at how to calculate the discomfort metric for one zone enclosed by this black box. We first need to calculate the total number of hours that the air temperature is outside the thermal comfort zone. And in these plots, we show the discomfort hours in the shaded orange and blue areas. Then we divide that number by the total number of occupied hours to get our metric as a percentage. And the lower the percentage, the better the zone is at maintaining occupant thermal comfort. And we can repeat this calculations for each of the zones in our building. And furthermore, we can repeat this calculation for each of the zones in the mortar data set. We almost have 2,000 zones from various buildings where we performed this analysis. And thus this application is portable. We can say that this application is portable across many buildings. We did not have to change any line of code to perform this analysis. And a preliminary analysis shows that most of the zones available within the mortar database indicates that they are generally providing thermally comfortable indoor temperatures, because a bunch of them have a low percentage of the discomfort, a low percentage of discomfort in them. So we are also interested in investigating the behavior of how occupants interact with their thermostats in commercial buildings. So we can easily adapt this application that we already built for thermal comfort analysis with just by changing one line of code. And so we can reuse this application for a different purpose, saving us time and effort. So the only line of code that we switch is actually just one word, going from a sensor just to a set point. So just by changing this, we are just returning all of the zone air temperature set points from the zones. And here we see box plots that are similar that we saw before in our thermal comfort evaluation, but this time we're evaluating thermostat adjustments made by the occupant. And a preliminary analysis of this data set shows that occupants interact with their thermostats, but not very much. Only like there was 48% of the zones, the thermostats were only adjusted less than 10 times. So the majority of the time, people do not care to adjust their thermostats, and even maybe just the building energy management system is adjusting it for them. So some of the next steps for this project is to continue to develop and expand the brick schema for its completeness, expressiveness, and usability. We will also continue to develop applications that take advantage of the capabilities of brick, and the applications that we built so far are available within a GitHub repository. You can also get involved with this open source project by donating building data, as I mentioned earlier, or joining the Brick Consortium, which allows you to steer the development of brick. Or if you're interested, you can also be involved in the working groups that focus on specific areas of brick. For example, you can be involved in expanding the concepts of brick, find better ways to use the data within the mortar data set, or develop tools that can make it easier to create brick models. And finally, there is a very active Google forum that can help you start incorporating brick into your project. So with that, I finish my presentation and I open it up for questions.
Thanks very much, Carlos. Really interesting presentation, and clearly there's a lot of applications and growth areas for this type of approach and being able to scale analytics and controls applications for buildings. Just for, because we've got, I suppose, in terms of the participants, we can allow people to unmute themselves and ask questions directly, but I'd ask just if you want to do that, as I said at the beginning, if you use the raise hand function, which is under the reactions icon on Zoom, or if you're having trouble with that, just type it into the chat and we can ask it directly. Just while I'm waiting, I had a couple of questions myself, and I'm sure a couple of other people on the call have some of their own. I suppose the first one that occurred to me was just where you see brick in comparison to, I know there's been other ontologies proposed for buildings. Where do you see ontologies like Haystack or other approaches, where do you see the kind of advantages of brick, and or even how they fit in with other approaches to building tagging and ontologies that have come before?
Yeah, so one of the ontologies that many people might be familiar with is the Project Haystack. And this Project Haystack uses a combination of tags to describe different building components. So it doesn't really have a formal structure to how to implement those tags to specific equipment. So there might be a variety of different methods to incorporate the tags and retrieve the information. So with brick, it's a little bit more structured. The labels within brick have a specific definition that if you say that this is a air handling unit, then the air handling unit has specific properties that you can connect different terminal units to it, for example. So I think one of the main advantages of brick ontology is that the relationships are more explicit, more structured, that it makes it easier for the brick modeler to figure out a structured way to define these definitions, I guess.
Thanks very much, Carlos. That makes sense. I might go to Adele first, if that's okay, Tony, and then come back to you. Hi, Adele. Good to see you.
Hello.
Yeah.
Hi, Daniel. Good to see you. Good to see you. And thanks very much, Carlos, for the presentation. Just a quick question. In the diagram where you showed the test bed, the mortar one, that's quite interesting concept. And I'm seeing that you have an API there, which is gRPC API. Is that a kind of a standard API that you that it's exposed somewhere that we can take a look at, or is something that the person designing this has to set up? And then, yeah, because that doesn't seem to be part of the brick specifications, unlike Haystack API, which has that specification. Just a question about that API aspect.
Yeah, so I'm not too familiar with the internal components of the software, the backend of the software, but Mortar is open source, so there's an API where you can use to retrieve the information using a Python module. Currently, this API is currently down because we're trying to figure out a permanent home for the whole database.
Okay.
So if you, let me look at the website. So if you go to this website that I will post in the chat, you can figure out more information about the whole Mortar database, how you can access it, and any information on when we can actually start retrieving information from the Mortar, because currently it's down for maintenance.
Okay, that's great. Thanks very much.
Thanks, Adele. I'll just go to Tony next, and then there's a question in the chat. So if you want to go ahead, Tony.
Carlos, thanks a million. That was a great presentation. I suppose, first of all, I'd just like to say it certainly shows the potential for big data. I think big data is always thrown around as a terminology, but it's so difficult with commercial buildings. At the application level, who do you see responsible for creating the schemas on a new building? Would it be like a consultant or the controls company themselves, or is it multifaceted? Is there multiple players involved?
Yeah, that's a very good question, and it's a question that come often. So ideally, I think the controls vendors would in my mind would make the most sense for them to be in charge of creating the brick model, because when they're implementing the controls, they're already going through the whole process of trying to figure out where the sensor is located, what is the controls equipment, what are the controls that equipment has to take on. So I think the control vendors are better apt to gather all this information. You can probably pre-populate a brick schema ahead of time using schematics from the building, but things change when things get implemented in the building, when they're being constructed or when the equipment is being installed. So I think the control vendors have that firsthand experience where they can actually have there would be less effort to get a more complete and accurate brick model.
I think you're right. I think it's definitely the controls companies are best placed. And I suppose at that level, were you suggesting that there's standardization around controls, implementing control strategy. Is that a potential benefit from brick schema? That,
there's already this effort at LBNL where they are trying to start a new ASHRAE standard on the standardization of controls. And let me go to the slide here. And that effort is called the Open Building Control Project, where they want to go from this standard program controls and have maybe different translation tools specific to each of the control vendors, where they can take that standard controls and translate it so it can be used within their own platforms. But the best thing with this demonstration project that we are using is that we are actually taking those standard controls with no modification and using it directly within our own application. So there's no translation involved. So we're just taking the controls that are programmed in the in the control descriptive language, and which is based off Modelica. I don't know if you heard of Modelica. So it just uses the same syntax to implement this control, and we're just using it straight in our controls application that we're demonstrating.
Very good, fantastic, thank you.
Thanks, Tony. So there was a question in the chat as well about the process for creating a brick model from an existing BMS metadata list, and whether there's an automated way of doing that, or is it a very much kind of a manual tagging process?
Yeah, so this is a good question. So since I started this project, I've been involved in creating several brick models from existing buildings, and sometimes it could be a challenge to create these models. And one of the biggest challenges is trying to make sense of this information. Sometimes there is drawings or schematics available that you can figure out what is the convention used for each of these buildings. And other times you really have to dig down into the specifications within the build controller to trace back a analog input 0 to whatever equipment. This is where the challenge can be. But I've done brick models where it takes less than an hour to implement, because all the naming conventions are pretty intuitive. Some of them you see here is the air handling unit. You can infer that it's using air handling unit 1, a constant air volume box 1 and 2 and 3 and 4, for example. But another one, the naming conventions can be pretty abstract, and you need a good communication with the building manager so he can give you access to the building management energy system, so you can follow where the data is coming from. So it depends. So one, it can be a couple hours to build, others can be a couple months or more.
Thanks, Carlos. Hopefully that answered your question, Flavia.
Oh, and about the second part, is there an automated way? Oh, yeah. Yes, there's companies that are have software packages that try to automate this process. So you just input a few examples of what your label convention might be, and then the software starts to infer the different connections. But I think these softwares have a limitation because sometimes there's implied information within these labels that the software cannot infer. So somebody has to go in there and figure out that implied information too.
Okay, thanks, Carlos. Adal, I don't know if you still have your hand up from earlier question, or is it just if you had another question?
Oh, apologies, I need to take it out.
No, that's no worries. I had another question myself, just if anyone else has any further questions, obviously just type them into the chat or raise your hand. We've got a couple more minutes. I had one, just you mentioned about open building control, I think based on the Modelica syntax. So I was just wondering, is there any linkage between the brick schema and simulation tagging or syntax in general? I mean, do you envisage that as being with this whole move towards digital twin applications and linking simulations to real building control. Is that something that you're looking at within BRIC as well?
Yeah, so I'm not working on that aspect specifically. There's another team members within the BRIC project that are looking at different translation tools. This includes upstream and downstream of the BRIC model. So you can, from a BRIC model, do a downstream translation and build a energy plus model or Modelica model where you can build a simulation model that you can use, or use a Revit or geometric model and translate it into a BRIC model. So these are all the different aspects that the project team is looking at to facilitate the whole process of just creating BRIC and the usefulness of BRIC models.
Okay, thanks very much. I know there's a couple of people from simulation background on the call, so maybe of interest. So one other question was in regards to looking at larger scale applications, kind of community level, district. Do you envisage BRIC being applicable to, you know, multitudes of buildings or districts and things like that? Or do you see it as more single building applications?
No, I think the benefits of BRIC start to go into where you start analyzing a collection of buildings. For example, building portfolio managers that have implemented a BRIC schema can quickly do a wide scale portfolio analysis of their buildings. And if everything is BRIC, then it's easy to retrieve the same kind of information from all the buildings, regardless of their complexity or uniqueness. So I think where BRIC starts to shine is where portfolio managers have large sets of buildings that they need to get information analyzed and figure out if they're performing well or where they can have improvement.
Perfect. Thanks very much, Carlos. If there's no other questions in the audience, I might just move on to closing announcements. I think we've got a couple minutes left, but I think it's been a very good discussion, and thanks so much, Carlos, for answering everyone's questions, and thanks very much, everyone, for all of your participation today. So let me just share my screen. I've just got a couple of minutes just for a few closing announcements before I switch off. Okay, so just very briefly before we wrap up, I just wanted to mention again, for anyone that's not been on any of our recent webinars in the last week or two, we have an upcoming mentorship program for young engineers or graduates in the early stages of their career, in pairing them with more experienced mentors, and we're having a first webinar as part of that mentorship program on the 25th of November, and we're currently accepting applications from both potential mentors as well as participants on that program. There is currently a number of mentors that are signed up, but we're planning to host this over the next year, so there will be further opportunities to participate if you're not available on this particular date. That's available on our website. Just to highlight as well, I suppose this is our current ASHRAE Ireland board for this society year. If you're interested in any of our activities, our contact details are on the website, on the link provided on the slide. And as always, we're interested in anyone that's interested in getting involved. Please do feel free to reach out to us, and we'd be delighted to welcome you to any of our meetings. Finally, just in order to stay updated with any of our upcoming training events, webinars, etc., do be sure to follow us on various social media channels, and also all of our previous events. As I mentioned at the beginning, over the last year and a half, all of our events have been online, and we have an active YouTube channel now where you can access recordings of all of our previous webinars. And finally, just to say thank you, sincere thanks to our sponsors and supporters who have been fantastic over the last year and a half as well in supporting our activity. And finally, just a big thanks again to Carlos for joining us from an early start in the West Coast of the US. And I really appreciate everyone as well for joining today's webinar a little bit later than our normal schedule. So with that, I'd just like to wish everyone an enjoyable evening, and look forward to seeing you again soon. Thanks very much for joining.
Thanks, Daniel.
Thanks, Carlos.